5.2.1. So last week we started on sequences. If you remember, we said a sequence is just a list of numbers in a particular order. We talked about the arithmetic progression. Now the arithmetic progression, these are numbers that have a constant difference. Between any two consecutive numbers, the difference is the same. So let's look at number 3. We're on exercise 5.2.1. So if we look at number 3, I hope you tried some of these. We are told that the third term, this is equal to 18. And we are told that the 50th term, this is equal to 347. Then we are asked to find A as well as D. So this one is pretty straightforward, nothing too complicated to do, because we just use the formula for the nth term. We know that un, this is A plus 1 minus n minus 1 times d. So for any term, if you know what n is, you can substitute it in there to work it out. So what we do is we rewrite this for u3. We know that u3 is 18, and here n is equal to 3. So this is equal to a plus 3 minus 1 times d. Then this part of the equation is what I'm going to concentrate on. I'll form a similar one with the 50th term, and then I will solve them simultaneously. So what I have is a plus 2d. This is equal to 18. So this is my first equation. Then for the second one, I use the 50th term. The 50th term is 347. And this is equal to a plus 50 minus 1 times d. So again, I'm going to concentrate on this side of the equation, or that part. Then I have a plus 49d. This is equal to 347. So those are the two equations. This is equation 1, and this one is equation 2. So I'm going to solve them simultaneously. Now, since the coefficients of a are the same, I will use elimination. So I will write a plus 2d is equal to 18, and then I have a plus 49d, and this is equal to 347. So it doesn't say to use elimination, so you're free to choose whichever method you want to use. Elimination is just my preference. When I subtract this, I get negative 47d. This is equal to negative 329. Then we divide by negative 47, divide by negative 47, you get d is equal to 7. So now that I know what d is, I will say a plus 2 times d, this is equal to 18. So I substituted this value of d into the first equation to solve for a. Then I get a is equal to 4. So now I know what a is, I know what d is. That is what the question had asked me to do. Then I am done. So you can always test and see if your answers are correct. Like I always say, check the solutions. So you know what the first term is. It is 4. Then the next term, 4 plus 7 is 11. Then the third one, I will get 18, which is what I was given in the question. Okay. And then you can also come up with a formula for UN and then check that U50 is the same as the one in your question to make sure that what you have done is correct. Let's do the next one. We have U5, the fifth term. This is equal to 3. And then the ninth term, this is equal to 5. Then we have to work out A and D. Okay, so this one, do it in pretty much the same way. We know that U5, or the fifth term, this is equal to 3. And this is equal to A plus 5 minus 1. So my n over here is 5 times D. And then I will concentrate on this part of my equation. So I have A plus 4D, and this is equal to 3. Okay, this will be my equation 1 that I will solve simultaneously with the other equation. Then I have U9, this is equal to 5, and this is equal to, I put the formula for the ninth term. So I have 9 minus 1, sorry, I have A plus 9 minus 1 times D, and this leaves me with A plus 8D, and this is equal to 5. So this is my second equation. Now I have two equations. I can solve them simultaneously. And then here also, because my coefficients of A are the same, I will solve them using elimination. So I have A plus 4D, and this is equal to 3. And then I have A plus 8D, and this is equal to 5. Because the signs are the same, I will subtract 4D minus 8D. This is minus 4D. 3 minus 5. This is equal to negative 2. Then I divide by negative 4. I get D is equal to a half. And then I will substitute D into the first equation. So I have A plus 4 times half. This is equal to 3. So I have A plus 2 is equal to 3. This means that A is equal to 1. So I solve for A and D, which is what I was asked to do. And look at number 6. With number 6, you're given this arithmetic progression. It's 1, 3, 5, 7, 9, and then it continues until we get to 61. Just a moment. Okay, so it continues up until you get to 61. Now the question is, how many terms have I listed, or how many terms do I need to write in order to get to 61? So I've obviously skipped a few over here, but I know that the last one is 61. Now the question is, how many terms do I have until I get to 61? So here we know what A is. We know that A is 1, and we know that 1 plus D is equal to 3. This means that D is equal to 2. So we know what A is, we know what D is. We can come up with an equation for the nth term. So we say that UN, this is equal to A plus n minus 1 times D. This is 1 plus n minus 1 times D, which is equal to 2. Now we know what the nth term is. It is 61, and we want to work out what the value of n is. Because if we know what the value of n is, that will tell us what term number it is. So what we do is we will say un is equal to 61, and this n is the one that we are looking for. But I know that un is equal to all of this. So I have 1 plus 2 times n minus 1. This is equal to 61. I'll subtract 1 on both sides. So I have 2 n minus 1. This is equal to 60. Divide by 2 on both sides. I get n minus 1. This is equal to 30. And then I will add 1 on both sides. I get n is equal to 31. So here you can say there are 31 terms. Okay, so this is another way that the question could be asked, where I list the terms and I tell you the last one that I have, or the one where I stop at, and then you have to tell me how many terms I have. So this is just the same as solving for n. Then number 7, we have 3, 10, 17, 24, and then the numbers continue in that way, and you can see that the numbers are increasing. Now the question is, how many terms do I need to write until the sequence exceeds 1000? Okay, so I'm not saying until I reach 1000. I want to find out what number, the number of terms that I need to write until I find the first number in the sequence that is greater than 1000. So here you can see my terms are increasing. Eventually I will get to 1000, I'll pass 1000. Now I will want to know at what point do I pass 1000. So to do that, so this is just saying the number of terms needed to exceed 1000. Okay, so what we do over here, we're looking for n. So we want un, which is greater than 1000. This is basically what we are saying. Now this un over here, it has a formula. We know that this is a plus n minus 1 times d, and we want this to be greater than 1000. So here from our sequence, we can see that a is 3. We say that a is equal to 3, and we know that 3 plus d is equal to 10. So 3, if I want to get the next term, I must add d. So I say 3 plus d is 10. This means that d is equal to 7. So I have my a and my d. I will just substitute them over there. So when I do that, I have 3 plus n minus 1 times d. This is greater than 1000. So first I will subtract 3 on both sides. So I have 7 n minus 1, and this is equal to 1000 minus 3. This is 997. Then you can divide by 7 on both sides. Sorry, not equal to. Okay, then you divide by 7 on both sides. You get n minus 1. This is greater than 997 over 7. And then I will add 1 on both sides. So I get n is greater than 1004 over 7. So that is what I have. Okay, so this value here, when you work it out, This is 1004 over 7. When you work it out, you get 143.4. But then you need to remember that terms are like people. You cannot have 143.4 people. That is not possible. To get half a person or a quarter of a person, a term is, this is the first term, the second term, there's nothing in between. So if we want our terms to exceed 1,000, it must be the 144th term. That will be the first term that exceeds 1,000. So here we will say the first term that exceeds 1,000 is U144. And with this we can always check. If we find U143, this is the formula. Okay, this is 3a plus n minus 1, 143 minus 1 times d, which is equal to 7. When I work this out, I get 997. Okay, and this is obviously less than 1,000. So the 143rd term does not exceed 1,000. So that is not what we want. But if we look at the next term, 144, this is 3 plus 144 minus 1 times 7. What we get over here, this is 1,004, which is greater than 1,000, and that is what we want. Okay, so when you have a decimal like this, and you want a term that exceeds a value that you are given, you have to go to the next term, because you cannot have a decimal term. Terms are discrete, so it's 1, 2, 3. There's nothing in between, just like with people. Okay. Then number 9. Now with number 9, we are told that these three terms, 3m minus 1, 6m, and 19, these are the first three consecutive terms of an arithmetic progression, and we are told to work out the value of m. Now consecutive means they follow each other, so you list them in the progression, they will come one after the other. The first one will be 3m minus 1, then you'll have 6m, and then you will have 19. Okay. Now, what we know about an arithmetic progression is if I have this term, to get the next one, I will just add d, and then I'll end up with this one. And when I have 6m, to get the next one, I will just add d. So what I have is this 3m minus 1 plus d. This is equal to 6m. That is a property of arithmetic progressions. You add your common difference to the first term, it will give you the second one. And here, if I have the second one, and then I add d to that, I will end up with the third one, like that. So this is two simultaneous equations. Remember, I want to solve for m. So I'll rewrite the first one, collect m and d on one side, the constant on the other side. So I'll subtract 6m on both sides. So I have minus 3m plus d. And this is equal to positive 1. And then here I have 6m plus d. This is equal to 19. So I want to solve for m. I get rid of the d. The signs are the same, so what I need to do is subtract. So I say negative 3m minus 6m, this is negative 9m, and then 1 minus 19, this is minus 18, divide by minus 9 on both sides. I get m is equal to positive 2. Okay, so I don't need to work out d. You can work it out just to know what it is, but it is not necessary because that's not asked in the question. So sometimes they will tell you to list the 3 terms so you can work it out. This is by the way, just for my own interest. So the first one was 3m, so 2 minus 1. Then the second one was 6m, which is times 2, and then I add 19. So this is 5, 12, and 19. So you can see the difference between those two is 7. The difference in those two is also 7. So this is indeed an arithmetic progression. Okay, then we look at finding the sum of a certain number of terms in an arithmetic progression. Now, a sequence of numbers that is added together is called a series. So if I start with a sequence like this, 1, 2, 3, and then it continues like that. Now, if I decide to add all the terms, I say 1 plus 2 plus 3 plus 4, and then I keep adding like this. This is what we call a series. So the first one where you're separating the terms with a plus, this is a sequence. And then the sum of all the terms in your sequence is called a series. Okay, so sequence, you're just listing the numbers. Series, you are adding the numbers. Now with an arithmetic progression, you can find out what the sum of the first n terms is. So we say Sn, this is equal to n over 2, and then we say a plus l. So here a, again, this is the first term. And here L is un. Okay, so if I know that the first term is 5 and the last term, or the where I stop, is 15, for example, I will just substitute them over there as long as I know how many terms I'm adding together. So this is one formula that you can use to work it out. Then there's another one. We have Sn. This is n over 2. 2 times a plus n minus 1 times d. Now, if you use either of these formulas, you will get exactly the same answer. So it doesn't matter which one you use, they give exactly the same answer. So we can look at some examples. The first one is we're told to find this sum, 99, 97, 95, and then we keep adding until we get to 25. Okay, so here you're not told how many terms you have. So first you have to figure that out and then use that in your equation. So I know I keep adding numbers starting from 99. So this will be my A. This here is my L. So I can use that formula if I want to, but in either case I need to know how many terms I have. So this is like the first question we did. We know what un is. Un, this is equal to 25, but we don't know what the n is. That's what we need to work out. So to do that, we know the formula. This is a plus n minus 1 times d. This is equal to 25. Now a is over there. We worked it out, or you can see it. It's 99. And then n minus 1. Now d, we know that 99 plus D is equal to 97. This means that D is equal to negative 2. So here I have negative 2, and this is equal to 25. And then work this out. It's a simple equation to do. You get negative 2 and minus 1. This is equal to negative 74. Divide by negative 2 on both sides. I have n minus 1. This is equal to 37. And then I add 1 on both sides. I get n is equal to 38. Okay, so now that I know what n is, I will check using both formulas if the sum, they give me the same sum. So I start with, here I will write S38 because that is the sum that I'm looking for. It's the sum of the first 38 terms. This is 38 over 2. The shorter formula was the first term and the 34th term, which is 25. And then you work this out on your calculator. You get 2,356. So that's what you get. Then you can try it with the other formula, S38. This is 38 over 2. 2 times 99 plus n minus 1, which is 38 minus 1. You multiply this by your constant difference, which is minus 2. And then work that out on your calculator. So if you've typed it out correctly, you should still get 2,356. So in either case, your answer is exactly the same. So it doesn't matter which formula you use. Okay, look at another example. Now with this one, we are told that the sum of the first 10 terms is 210. And then when you sum up the next 10 terms, so here this is the next terms, we get 610. So we have to find the arithmetic progression. That means we list the first 4 terms. Now this one, you need to always make sure that you read the question correctly and you understand what it is saying. Now it's not saying that the sum of the first 20 terms is 610. So it's not saying this. This is not what it is saying. That is incorrect. What it is saying is if you have your terms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you add all of these up, you will get 210. Then you have 11, 12, and then you continue up until 20. When you add these ones here, what you get is 610. Now this formula Sn that I have given, it doesn't calculate formulas of terms in the middle. It always starts from the beginning up until a certain point. Okay, so you cannot, it doesn't calculate sums like here from 11 to 20 and leave out these ones. You will have to calculate that, make your own formula for that. But here, this is what it is saying. When I add up term 1 up to term 10, I get 210. And then when I add term 11 to term 20, I get 610, sorry. Now the question is, what is this sequence? Okay. Right, so to do this, I can work out the sum of the first 20 terms. Now the sum of the first 20 terms is just 210 plus 210 plus 610, because if I know what the sum from 1 to 10 is and from 11 to 20 is, to work out from 1 to 20 is just to add everything together. So this is just equal to 820. Then what I do is I will use the formulas for Sn. So I know that Sn is equal to n over 2a plus n minus 1 times d. Now I know what n is. So the first one I have S10. This is 10 over 2a plus 10 minus 1 times d, and this is equal to 210. That is given to us in the question. And then I have S20. This is 20 over 2. I have 2a plus 20 minus 1 times d, and this is equal to 820, not 610, because 610 is the sum of the numbers from 11 to 20, not from 1 to 20. And S20 means the sum of the numbers from the first one up until 20. Okay, so I can simplify each of these equations and then I will solve them simultaneously. So you'll notice in this chapter we're doing a lot of simultaneous equations. So you need to know how to do those types of questions. So when I simplify the first one, I have 5 2a plus 9d. This is equal to 210. And the second one, I have 10 2a plus 19d. And this is equal to 820. Then I can still simplify further. Divide by 5 the first equation, divide by 10 throughout the second equation. So I will have 2a plus 9d. This is equal to 42. And then 2a plus 19d. This is equal to 82. And then I will use elimination because the coefficients of a are the same. And then I will subtract. So 2a minus 2a is 0. 9d minus 19d, this is minus 10d. And then 42 minus 82, this is minus 40. This means that d is equal to 4. And then to solve for a, I will substitute the value of d into the first equation. So I have 2a plus 9 times 4. This is equal to...
Miss.
Yes. Yeah.
How did you get that number 5 and number 10 at the beginning of the brackets for the one we solved simultaneously?
This one here.
Which one? Oh, yeah. Oh, okay.
Is it fine now? Is it okay now?
Yeah, it's fine.
Okay.
Yeah, it's okay, but did we use those one in the brackets?
Which one's in the bracket? Because this,
5
I
and
have
10.
10. No, I divided by them on both sides. Because you see here, I had 210. Now I have 42. So I've divided both sides by them.
Oh, now I
Yeah.
understand this.
Okay.
Thank you.
Then I multiply the 9 and the 4. Then I get 2a plus this 4. Sorry, this is 42. Okay, then 2a plus 36. This is equal to 42. And then 2a is equal to 6, this means that a is equal to 3. So now that I know what my a and my d are, I can work out the sequence. So the first term is 3. Then to get the next one, I say a plus d. My d is 4, so I say 3 plus 4. This is 7. And then 7 plus 4, this is 11. And then 11 plus 4, this is 15. Okay, 4 terms is enough to show what the sequence is, because the difference between any two consecutive terms is constant. Then let's look at another one. We start with the exercises now. This is exercise 5.2.2. Here we are given this series continues up until the 50th term. So we have to find the sum of the first 50 terms in this series. So remember, a series, that means you're adding all the individual terms of the sequence. But a sequence, you're just listing the numbers. So here we know what the first term is. It is 3. We can work out what d is. So I have 3 plus d. This is equal to 9. This means that d is equal to 6. So d is 6, and we know that a is equal to 3. So all I do is I now substitute my a and d into my formula for Sn. The formula for Sn is, sorry, let me make it S50. This is equal to 50 over 2. Then we have 2 times a, which is 3, plus n minus 1, which is 50 minus 1. And then this will multiply by d, which is equal to 6. So you write that in one nice straight line. So this is 25, 6 plus 49 times 6. Okay, so that's what you have. Then this, you just work it out on your calculator. Should get 7,500. Is that what you're getting? Can somebody confirm, please, if that is the right answer or not?
Yes, Ruth, it's the right answer.
Okay, thank you. Then let's look at number 3. So still on exercise 5.2.2. With number 3, we are told that the sum of the first 20 terms, this is equal to 420, and the sum of the first 30 terms, this is equal to 930. So again, very important that you read the question correctly. Otherwise, the way you write your information will not be correct. So it doesn't say the sum of the next 30, it says of the first 30. And the first 30 includes the first 20. So we're told that S20 is 420, S30 is 930. Then what we are asked to find is the first term and the common difference. That is what we need to work out. So to do that, again, we will have to form simultaneous equations, which by now I'm sure everybody knows how to solve. So let us do that. Write down the formula. We know that S20, this is equal to 20 over 2. And then we have A plus 20 minus 1 times D, and this is equal to 420. So this equation over here, this is what we will focus on. And then we know that S30, this is equal to 30 over 2. And then we have A plus 30 minus 1 times D, and this is equal to 930. So again, this is what we will focus on. So when I simplify here, I have 20 divided by 2, that's 10. 20 minus 1, that's 19. Same thing here, 30 divided by 2 is 15. 30 minus 1, this is equal to 29. So simplifying the equations, what I get is 10 A plus 19D. This is equal to 420. And then I have 15 multiplied by A plus 29D. This is equal to 930. So from equation 1, I'm going to divide by 10 on both sides. And equation 2, I will divide by 15 on both sides. When I do that, I will have A plus 19D. This is equal to 42. Then I have A plus 29D. This is equal to 62. Then we can use elimination to solve this because the coefficients of A are the same. The signs are also the same, so I will subtract. Then I have 19 minus 29. This is negative 10D. And then 42 minus 62, this is negative 20. And then I divide by negative 10, divide by negative 10. This means that D is equal to 2. Okay, so if D is equal to 2, I can substitute that into the first equation here and then solve for A. So I have A plus 19 times 2. This is equal to 42. So this means that A is equal to 4. So 19 times 2 is 38. 42 minus 38 is equal to 4. Okay? And somebody tell me if that is correct. Is my working fine?
Yeah, it's
Yes, yes,
fine.
the working are fine.
Okay. Do we have any
Yeah.
questions so far?
So far, so good, man.
Okay. Okay, let's look at the next question. Okay, number 5. We are told that an arithmetic sequence has a common difference D, and then the sum to 20 terms is 25 times the first term. Find in terms of D the sum to 30 terms. Okay, so this one again is just a matter of you reading the question correctly and understanding what it is saying. So this is number 5. We are told that the common difference is just D. And then we are told that the sum to 20 terms, so S20, this is 25 times the first term. So this is 25 times the first term. Okay? Now we have to find in terms of D the sum to 30 terms. So we have to find S30, what this is. Okay, so read the question, make sure you understand it, and then translate that into equations that you can solve. So we know that S20 is 25A. Now we want to work out what the value of S30 is. So S20, we can write down this as 20 divided by 2. And then here we have 2 times A plus n minus 1. This is 20 minus 1. And then D, which we are not told. So we have to give our final answer in terms of D. Then we can simplify this, 20 divided by 2. So we're only concentrating on this part of the equation. But we also know it is equal to 25A. All right. So what we will do here is we have 10, that's 20 divided by 2. And then inside my brackets, I have 2A plus 19D, and this is equal to 25A. Okay, and then I can multiply out my brackets here. Here the reason I'm not dividing by 10 on both sides, because on the right hand side I have 25. So when I multiply that out, I'll end up with a decimal, and I don't want decimals, so it's better to just multiply brackets out. Then what I have is 20A plus 190D. This is equal to 25A. Then what I will do is I will collect all the terms on one side, just have 0 on the other. So I can subtract 20A on both sides. So I will have 5A minus 190D, and this is equal to 0. Now we have to keep in mind what it is we are looking for. We're looking for the first 30 terms, and we want our answer to be in terms of D. Okay, so if our answer is in terms of D, it means that we will have to rewrite A in terms of D as well, so that our equation has only D in it. So we will use this equation over here, and then you make A the subject of the formula. So you have 5A minus 190D, this is equal to 0. This 5A is equal to 190D. Then you divide by 5 on both sides. You get A is equal to 38D. Okay, so now I have a formula for A. To find the first 30 terms, all I do is S30. This is equal to 30 divided by 2. 2 times A, but my A is this one over here in terms of D. This is 38D. And then say plus 30 minus 1 times the common difference, which is D. Then simplifying this, I get 15. 38 times 2. This is 76. I have 76D plus 29D. And here you can simplify what you have inside the brackets. You add the 72D and the 29D, you get 105. So I have 15 times 105D, and then you multiply this by 15, you get 1575D as your solution there. Okay, somebody says my screen, is it not showing? Can you see it? I hope you can see it now. Okay. Right, let's look at number 6. We're told that we're told that 3 consecutive terms, so it's not really the first 3, it's just 3 consecutive terms that they follow each other, have the sum of 36 and a product of 1428. Find the 3 terms. So I have term n, not the sum. I have this term, I have un plus 1, and then I have un plus 2. These are the 3 terms that I am looking at. Not necessarily the first 3. It can be term number 10, 11, and 12. It can be 100, 101, and 102, as long as they follow each other. Now the sum of these terms, un plus un plus 1 plus un plus 2, we are told this is equal to 36. And when I multiply them, un times un plus 1 times un plus 2, this is equal to 1428. Okay, now the question is, what are these terms? Okay, so this one over here, again, we will have to use our simultaneous equations. We know that if we want to work out the nth term, we say un, this is equal to a plus n minus 1 times d. Okay, now if I have un and I want to get un plus 1, to get that, all I will have to do is say un and then I add d, isn't it? I just add d because the difference is constant. And then if I want to work out un plus 2, here I will just say this un plus d, I add another d, so this is the same as un plus 2d. Okay, so this is the general formula for un. To get the next one, because I'm talking about consecutive terms, they follow each other. To get the next one, I must just add d, and the one after that, I add another d. That means I add 2 d's to the first one over there. Okay, then when I add all these 3 terms together, the first one, the second one, and the third one, the answer must be equal to 36. So I can simplify un. So for un, I will have a plus n minus 1 times d, and then un plus 1. Here, I think I should multiply out the brackets, then I can collect my d's. So this is just a plus nd minus d, and then un plus 1, this is a plus nd minus d, so this is un, and then I add a d, which is what I said to do over there. This will give me a plus nd, and then the next one, un plus 2. For this one here, I add a d to it, so I have a plus nd plus d. Okay, so now I have my 3 terms. This is the third one, this is my second one, this is the first one. When I add them all together, what I should end up with is 36. So I have A plus ND minus D plus, this is U1, and then I add A plus ND, and then I add A plus ND plus D, and this is equal to 36. Okay, so we simplify as far as possible. Now you can see here I have minus D and D, those two will cancel out. Then I have A, and A, this is 3A. And then I have ND, ND, and ND, so there's three of them, plus 3 ND, this is equal to 36. And then what I do next is I can divide throughout by 3. So I have A plus ND, this is equal to 12. Now this is my first equation that I will use to solve simultaneously. Then the product, I just need to multiply all three of these. So it'll be this times this times this, equate to 0. Sorry, not to 0, equate to 1, 4, to 8, and then I will solve them simultaneously, because we did equations where one of them may be non-linear, but you are still able to solve that one. So doing that, I have let's see. Okay, maybe I'm going a very long way. Okay, we multiply them. Let's see. We have A plus n minus 1 times D. Then I multiply with the next one. I have A plus ND. And then I multiply that by A plus ND plus A plus ND plus D. This is equal to 1, 4, 2, 8. Okay, whew, this will take a very long time to multiply out. But if we do, then we can make A the subject of the formula in the first one and then substitute it into the second equation. It seems like this just goes a very long way. Okay, let's just stop here for today. You can multiply this out and then try and substitute, and we'll continue from here tomorrow. Do you have any questions? Or are we fine? It's just silence. Okay, nobody's there. Right, then I will see you guys tomorrow. Go and multiply this out and let's see what we get. I think I'm doing a too long process, but we'll see about it tomorrow. Okay, so I have another class now. Let me go and join that one. Okay.